Alright, this is part 2 of our review of right triangle trigonometry. Again, put your pencils down, watch and learn, do not copy, go back and do the problems by yourself. It's the only way that you're not going to fail your next test. Alright, believe me people, this is like 23 years of teaching, talking. Let's get down to business. Problem number 2. Alright, which expression could be used to find the value of x in this diagram? Okay, so I'm looking at this diagram. I see the 35. Alright, so I see a couple of 35s here, but I also see this 55. Where do you think they got that from? Well, this is very important. Let's focus on this for a second. Where's the 55 coming in? Well, I wonder what this other angle is right here. How would I find out? These two angles are complementary. If I want to find the other angle, I should do 90 minus the first angle. Am I right? What is 90 minus 35? Oh, 55 degrees. Okay, so that's where they're getting the 55 from. So let's keep that in mind as we do these problems. So we know that cosine is adjacent over hypotenuse. Okay, so they got 55 here, so let's look at the 55 and think adjacent over hypotenuse. Okay, so from the 55, 12 is adjacent, and of course x is the hypotenuse. So that would be the cosine of 55 should equal adjacent over hypotenuse. We could solve this and find x. Okay, so 12 over x, but they have x over 12. All right, so that's not it. Alright, let's pretend I don't notice that it's right here. So I go on to B, cosine of 35. Okay, so I look at that. I change color so I don't get confused. Cosine of 35. Well, that would be adjacent over hypotenuse. We don't even have the adjacent leg. Alright, so cosine of 35 would be like mystery angle over x. Alright, we can't use that because we don't, it's a mystery angle, question mark, unsolvable. So it can't be B. It can't be B. It won't be B. I pity the fool, use B. So if you look at C, cosine of 35, let's see, cosine, wait, didn't we just do that? Yeah, I just talked about you can't do cosine of 35 any kind of way. It's not going to be 12 over x. It's not going to be x over 12. Alright, it's going to be mystery angle. So only D is left, and we really already talked about it. See, it's right here. The cosine of 55, okay, up here, adjacent hypotenuse, 12 over x. 12 over x. Kabam, 12 over x. D is the correct answer. Okay, hot diggity dog. That was number 2. Now, number 3, find the sine, the cosine, and the tangent. I'm mad that they wrote out cosine, alright? They didn't just put cos, and they wrote out tangent. But for sine, all of a sudden they abbreviated it with the sin. Why? Let's be consistent, people. Alright, find the sine, the cosine, and the tangent of angle A. Express each value as a fraction and a decimal. Okay, angle A, it's all about angle A. Sine, cosine, and tangent. Ever get the feeling you're zoomed in too close? Okay, let's zoom out a bit. Okay, anyway, here's angle A right here. And first we're supposed to be doing the sine of it. So sine is opposite over hypotenuse. So that's 3 over 5. Okay, so the sine of angle A is 3 over 5. Okay, we'll go back and do the decimals later. The cosine of angle A, alright, cosine is adjacent over hypotenuse. So that would be 4 over 5. Okay, and the tangent of angle A. Tangent is opposite leg over adjacent opposite over adjacent. So that would be 3 over 4. Okay, and now the decimals. Alright, so I believe we had 3/5. And that's 0.6. Whoa, did I hit the wrong button? I did. So yeah, 3/5 is 0.6. Okay, and then we had 4/5. Alright, maybe I'll do 4 divided by 5 this time. Save me a step. That's 0.8. And 3/4. Alright, you should memorize that 3/4 is 0.75. 3 divided by 4, 0.75, like I said. Okay, and that's it for number 3. Great. Alright, let's look at number 4. The sonar operator on a ship detects a submarine a distance of 400 meters at an angle of depression of 35 degrees. Okay, angle of depression, the angle that he's looking down, 35 degrees, 400 meters. Okay, great. How deep is the submarine? Okay, well, how deep is the submarine? That's a great question. We're talking about this distance right here is the depth of the submarine. Okay, which trig function, alright, nearest tenth, which trig function are we looking at here? From the 35, we're dealing with opposite and hypotenuse. That's the sine function. So we will say sine 35 is equal to opposite over hypotenuse, that is x over 400. Okay? This is a situation where we will multiply it by 400 on both sides, multiply by the denominator. Okay, just put this in your calculator. 400 sine 35. Whoops. Okay, that's 229.4 meters. Yep, okay. That's it for number 4. Alright, let's take a look at number 5. A new store is being built and an escalator is planned. It will make an angle of 34 degrees with the floor. If the vertical distance between floors is 14 feet, how long will the escalator be? Okay, nearest tenth. Look, this is like when I ask you how long is a ramp or how long is a ladder. Okay, the length of the escalator is this length here. Okay, this is the length of the escalator. Okay, the escalator is this the stairs, you know, it's the part that you walk up or stand on. Alright, that yellow part there, that's the escalator. Alright, the rest of this is like the ground or whatever. So if I say how long is the escalator, I'm not talking about down here at the bottom on the ground. I'm talking about the hypotenuse. You know, just like a ramp or a ladder. Okay, that was important because last year I had like 15 kids finding this distance down here, and it broke my heart because most of them did the work right, but they just were misinterpreting the question. Okay, anyway, if I want to find the length of the escalator, which trig function am I going to use? Well, this is opposite from the 34. This is opposite, and this is hypotenuse. That is the sine function. So I will say sine 34 is equal to opposite over hypotenuse. See how the variable is in the denominator? That's when you want to reverse. Okay, you want to swap these out. So this is going to give you x over here is equal to 14 over sine 34. Alright, then you can just put this in your calculator. Alright, this will be feet, by the way. So 14 over sine 34. It's 25.0. feet. Okay, that is the length of the escalator. Alright, and that was problem number 5. Alright, let's move on and take a look at problem number 6. Okay, you are looking at the top of a lighthouse, and you are 22 feet from the base of it. Okay, a little piece down here. You measured the angle of elevation to be 72 degrees. Okay, that's this right here. Alright, how tall is the lighthouse? Alright, 1 decimal place, 1/10 of a foot. Alright, this is a really tiny triangle. I feel like I want to make it bigger so I can see it better. Alright, I have a feeling that you will not mind. Okay, so this little triangle right here will now become this triangle right here. So my triangle will be pink, because pink is awesome. Alright. Now what? So the 22 is down here. Okay, as you can see, 22 feet. And this angle of elevation, yeah, I mean this is 90 degrees. This angle of elevation right here is 72 degrees. Okay, and we're supposed to find the height of the lighthouse. So that would be like this right here. Okay, so yeah, from the 72, this is opposite leg and this is adjacent leg, because this is the hypotenuse here, question mark. Opposite over adjacent. So the not the trig function, the tangent function is opposite over adjacent. So that's why we will go tangent of 72 degrees is equal to opposite over adjacent. Okay, am I going to do the swap? No. When the variable is in the top, the numerator, you want to just multiply both sides by the denominator. That way these will cancel out. Okay, so that's going to give me the height of the lighthouse here. So 22 tangent of 72. So 22 tangent of 72. Alright, that is 67.7. Okay, so that is 67.7 feet. That's how tall the lighthouse is. Alright, that is it for number 6. Alright, let's take a look at number 7. What is the approximate measure of the acute angle A when the tangent of A is 0.698? Well, if I told you once, I told you at least 74 times. How do you find the angle out of things? How do you get the angle? Inverse trig functions. I hope I have thoroughly drilled into your brain. Inverse trig functions. So if the tangent is equal to this, alright, if the tangent of A equals this, A will equal the inverse tangent of this number. Okay, So inverse tangent of 0.698. Alright, to do the inverse tangent, you do second tangent, okay? So inverse tangent of 0.698. Okay, that gives us 34.9 degrees. This is an angle now, so degrees. So there it is. The answer is C. Speaking of degrees, probably should have mentioned this earlier. But please make sure your calculator is in degree mode. There's another mode, alright, in your calculator called radian mode. Alright, just to make a point, if I switch to radian mode, see how it says RAD right there? Alright, sometimes your calculator can get accidentally switched to this mode, and all your answers on the whole test will be wrong if you have it that way. So please just make sure your calculator says DEG for degree. Okay, just wanted to emphasize that. Okay, alright, I'm just going to do one more problem on this video, because then it changes to like a different type of problem. But number 8 is similar to the other problems we've done. So let's go ahead and include it in this set. You pitch a tent as described below. What is the measure of angle A? Slow down. If I ask you what the measure of the angle is, how have we discussed finding the measure of angles? What did I just say? Not 5 minutes ago. If you want to find the measure of the angle, you're going to need inverse trig functions. Is that what you were thinking? Well, good for you. Go get an A on the test. Inverse trig functions. So just keep that in your mind. Let's go. Angle A is right here, so just focus on that. From angle A, okay, and really just look at the left side of this triangle. That's all that we really care about right now. Okay, yeah, so there's angle A. 3 is adjacent, and of course 8 is the hypotenuse. Adjacent, hypotenuse, that's right, the cosine function. So the cosine of A is adjacent over the hypotenuse, 3 over 8. So if you want the angle out of it, you're going to need the inverse cosine. So the inverse cosine of 3 over 8. And you can just put that in your calculator. Okay, let's see. So the inverse cosine, so second cosine of 3 over 8. And that is 67.97. Alright, because of the 7, I really need to round this 9 up. Okay, but it's already a 9, it's the highest digit. So instead, look at, let's see, I have never done this before. Can I draw with this thing? Oh, look at that. I'm drawing on the calculator. It's pretty cool. Yeah, so since 9 is already the highest digit, look at these two numbers, 79. This 79 is going to become 80. Okay, like this. So like 8.0. Alright, and I still got the 6. So this will become, instead of 6 and then 79, it'll become 6 and then 80. So 68.0. Okay? Alright, that was interesting. And that is degrees. We are talking about an angle. So that is the answer for number 8. Alright, that's plenty enough for one video, and we will pick up the third part of our video with problem number 9 and 10, where we're looking for side lengths that could possibly form a triangle.